from there. So as we know that guys, we are going to derive the equation for law of conservation of momentum. So what do you mean by law of conservation of momentum? Law of conservation of momentum will says what? The momentum before collision will be equals to momentum after collision without any applying external force. Is it yes or no? Yes, please. So that is what we can say law of conservation of momentum. Momentum neither be created nor be destroyed, or never created or destroyed. That is what we studied in the last class. So if we'll take before collision, we consider two vehicles. What is the two vehicles we have been consider? That vehicles only we can say what? One is a truck and another one is what? Truck and another one is what? A car. So both are moving with different velocities in the same direction. That is what we have been assumed. Initial velocity is u1 and this car initial velocity is what? u2 and the truck mass is m1 and the car mass is what? m2. So this is what? Momentum before collision. Is it yes or no everybody? Momentum before collision. So that is what you can take. So momentum before collision is equals to what? Which is equals to momentum of the truck plus momentum of the car. So that momentum of the before collision, let me take before BC. BC means what, Hari? Before collision, okay? Which is equals to momentum of before collision is equals to, what is the momentum of the truck? Anybody? Momentum of the truck is M1 U1 plus car is what? Everybody. M2 U2. Do you understand? Next. During collision, they are colliding each other. That is what will happen? They will hit each other. That is what? Collision will take place. So collision means they will hit or not both each other. Please respond. They will hit or not? So that is what you can draw. So they have been hidden by each other. So now car is going to, both the truck and car is going to hit each other so that some sparks will come. Okay. So collision. So collision after what will happen? This is the A diagram and this is the B diagram. Collision after what will happen? Again, they will be separate out and they will be moving the same direction or different directions, everybody?
Same direction.
Same direction, understand? But some damage will take place at the front part. For car, from the back part, it will be some damage. So now what is the velocities after hitting, after collision? Momentum after collision, anybody? Momentum after collision, mass is remains same, mass is m1, car mass is what? m2. So after collision, what is happening? Mitakshri? So after collision, where final velocity is v1, after collision, final velocity is what? v2. Is it yes or no? Please respond. v1, v2 is to call that final velocities. What is that? Final velocities after collision. So momentum after collision, anybody can tell? After collision, BC means before collision, AC means after collision. So momentum after collision is equals to what? Momentum of the truck plus momentum of the car after collision. Anybody can tell me the equation? Momentum of the car, which is equals to what? Sorry, momentum after collision is equals to m1 into v1 plus, you should speak, m2 into v2. Okay, this is what. Now, what is the definition of, anybody can tell what is the definition of law of conservation of momentum? You studied in the last class. What is that? When two bodies act upon one another, when the two bodies act upon one another, their total momentum remains constant or conserved, provided no external force. That is the definition of law of conservation of momentum. Is it right or not, Hari? Kaushik? That is what. So
yes,
we can say momentum is never created or destroyed. That is what we studied in the last class. Yes or no, guys? Please respond. So from that we can say conservation of momentum means we can all can say that conservation of momentum, which is equals to what? M1 U1 plus M2 U2, which is equals to what, Hari? Mitakshri, M1 V1 plus M2 V2. This is what? Momentum before collision must be equals to momentum after collision. Is it right or wrong? Yes, please respond. Momentum after collision. This is what you have to remember it. Now we have to prove this one. Shall we prove? Everybody, are you ready? Yes, please.
Yes, sir.
Now, as we know that for the proving, let me take from the Newton's third law. From the Newton's third law, please everyone respond. From Newton's third law. What is Newton's third law? Anybody can tell? What is the Newton's third law? Gokul Krishna.
Every action has a equivalent reaction.
Yeah, every action there is an equal and opposite reaction. That is what. So if you take from Newton's third law, every action is equals to there is an opposite and equal reaction. Is it yes or no? Yes, please respond.
Yes,
now, let's consider the force exerted by a truck is F1. The force exerted by a truck is what? F1. Do you understand, everyone? So now you tell me, 1 minute, I will erase it. I'll draw truck. Now let's consider force exerted by a truck is what, guys? Force exerted by a truck is what? Yes, please respond. Let's consider force exerted by yes. Force exerted by truck is F1 and car is what? Car is what, guys? Car is F2. Is it okay, everyone? Now, we know that apply this one as a Newton's third law, then what will happen? Apply this F1, F2 as a Newton's third law. Action is equals to whom? Action is equals to F1, which is equals to, reaction is equals to what? Reaction is equals to what?
Minus.
Minus F2. Is it right or wrong? Will you accept it or not, everybody? Force exerted by a truck, which is equals to force exerted by a car on the truck, which is always opposite direction. Will you accept it or not? That is what my first question. Is it okay, everybody? Yes?
Yes, sir.
Now,
Yes, sir.
you tell me, when the force applied, F1 force of the truck is acts on the car in a particular time period T, then whose velocity will change, guys? Whose velocity will change? Car velocity or truck velocity? Suppose car is exerting force on, truck is exerting force on car. Then whose velocity will change? Car velocity or truck velocity? Anybody? Suppose
Sir, both velocity will change.
no, listen, that is what. If I am applying force on you, Hari, so you will hurt or me will hurt?
Yes, sir.
You will hurt. Then when you are applying force on me, who will hurt? I will hurt. Is it yes or no? Please respond. So due to, I am asking the question here, due to the force applied by truck will change the velocity of whom? That is what my question. Anybody can answer. It will change the velocity of whom?
The car, sir.
Car. Now, car will apply force of F2. Due to the force applied by the car, whose velocity will change? Whose velocity will change? Try to answer, guys. F1 is applied by truck. Do you understand? F1 is applied by truck. Applied by truck on whom, guys? Open your mouth and tell me. Applied by truck on whom? On car. So whose velocity will change? Car velocity will change. Car velocity will change. That is what will happen. So F1 is applied by a truck, understanding, in a given period of time. That is what, for a time T, truck on car, understanding, for a time T, for a time T, then the car velocity will change. So F1 is equals to what will come? Formula tell me, F1 is equals to what will come? Whose velocity is going to change? Because of F1, whose velocity is going to change? Basically, we know that from the Newton's second law. From Newton's second law. Tell me, what is the Newton's second law? From Newton's second law. From Newton's second law, I'm asking formula. From Newton's second law, F is equals to what? Mass into acceleration. Is it yes or no? Yes, please.
Yes, sir.
Yes. Now, F1 is equals to, let me take, here whose mass is? Car mass or truck mass? It is applying on car. So that mass of car into acceleration of car. Is it right or wrong? Yes, please.
Yes, sir.
Everyone, that is what. Now, what is the car acceleration? Everyone tell me formula. Car acceleration. Check it in the diagram and tell me. What is the car acceleration? final velocity minus initial velocity in a given period of time. So that what is the formula will come? V2 minus V1 divided by what? T. That is what it is, F1. Let me assume this is equation number 2 and this is equation number 1. Is it any doubt? Anybody can ask. Are you clear? F1 is applied by truck on car for a time t. So car velocity will change. So car velocity will change from where to where? From U2 to V2. Is it yes or no? Because U2 is the initial velocity, V2 is the final velocity. Now same way, F2 is applied by whom? Everybody. F2 is applied by car on whom, guys? Car or truck. Okay, truck for a time t. So whose acceleration will change? Whose velocity will change? So truck velocity will change. Truck velocity will change. Do you understand, everyone? Now, from Newton's second law, as we know that from Newton's second law, force is equals to what? Mass into acceleration. Okay, that is what. So that from Newton's second law, so F2 is equals to what will become? F2 is equals to force. F2 is equals to anybody? M1 into A1. Is it right or wrong? M1 into A1. Will you accept it or not? Everybody. So that is what you have to remember it. Now, everyone can tell me what is the acceleration of the truck? Anybody? So force F2 is equals to mass of the truck into acceleration of the truck. What is the acceleration of the truck? Change in velocity. Check it, everybody. What is the initial velocity of the truck? U1. Final velocity of the truck is V1. So if you will rearrange, so what is the acceleration formula? If you will speak, it is nice. Tanishkar, Arun Kailash?
V1 minus
Yes.
V1 minus U1.
V1 minus U1 divided by what? Time period. Is it right or wrong? Everyone clear? Any doubt? Mitakshri? Vartini?
Sure.
What? Let me assume this is equation number 3. Is it okay? Gokul? Danishkar? That is one. Now you know F1 and F2 value. So I can substitute in where? Where I can substitute? In equation 1. Okay?
Sir,
Yeah, Hari. Ask me.
sir, in the second equation, you put like V2 minus V1, sir.
V2 minus V1, not U1. Sorry. It is
Yeah, but
U1. Yeah, sorry. Yeah, it is V2 minus U2.
U2.
Yeah, very good, Hari. V2 minus U2, guys, because initial velocity of the car is U2, final velocity of the car is V2. So V2 minus U2 divided by T. Is it okay? Yes, that is what. Now we know equation 2 and 3, F1 and F3 values. So what I can do? Substitute. You have to tell. Substitute equation 2 and 3 in where? In equation 1. Okay, everyone? Yes, please. Now, what is the equation 1? We all people knows. What is the equation 1? F1 is equals to, what is the ready? F1 is equals to minus of F2. Is it okay, everyone? Now tell me what is the F1 value? You all people know F1 value. M2 into V2 minus U2 divided by T, which is equals to minus of, what is F2? What is F2, guys?
Final.
M1 into bracket minus is there, so that I am keeping one more bracket. M1 into, what is that? V1 minus U1 divided by T. Any doubt? Anybody can ask. Are you clear? Yes, please. Now, multiply this with mathematics. A into B minus C. How we can multiply? A into B, AB minus A into C, AC. Is it yes or no? Yes. Same way here. Multiply it and tell me. M2 into V2. What is that? M2 V2. Next. Minus M2 into U2. What will come? M2 U2. Is it okay, everybody? Yes or no?
Yes, sir.
Now same way, forget about here minus. Minus you keep. Now inside you tell me. M1 into V1. What will happen? M1 V1
M1.
minus M1 into U2, M1 into U1, what will happen? M1 U1 divided by time period. Is it right or wrong? Everybody? So here I forgot
Yes,
time
sir.
period. Now, both the sides time period is in division. Can I get cancel? Will you accept it? Yes, please. Is it will get cancel or
Yes.
not? Both the sides time period will get cancel or not? Mitakshri, can you answer time period will get cancel or not? Danishka?
Yes, sir.
Yes. So both side are division. So now this t will come, this side will become multiplication so that it can get cancelled. Now itself, can I get cancel or can I bring it this side? Your choice. Do you want to bring it?
We can
You can cancel. Will you understand or not? That is what my question. If I cancel it, will you understand? Akilan? Akilan, answer my question. Danishkar?
Sir.
Yes. So I will get cancel the TT. Is it okay, everybody? Now what is remaining equation? Tell me. M2 V2 minus M2 U2, which is equals to minus of M1 V1 minus M1 U1. So in mathematics, minus of A plus B. For example, if you want to remove the bracket, what about the sign convention? Inside all the plus will become minus, minus will become plus. Yes or no? Yes.
Yes, sir.
Now here A is having plus, so that it will become A minus into plus minus A minus into plus minus B. This is what the answer. Yes or no, guys? Yes.
Yes,
Now
sir.
same way, here I want to remove the bracket. Then you tell me minus into plus, what will happen? Minus M1
Minus.
V1. Understanding? Next minus into minus, it will turns into plus. Plus M1 U1. Is it right or wrong? Everyone? Yes, please respond. Yeah. Now I will arrange all the initial velocities one side and final velocities one side. Is it right or wrong? Check it. Now here minus M1 V1 is there. If it will come this side, what will become? If
Plus
it will come this
M1
side,
V1.
M1 V2 equals to minus M2 U2 plus M1 V1, which is equals to M1 U1. Is it right or wrong? Now,
Yes, sir.
here minus M2 U2 is there, which will come this side. What will become? Ready? It will become what? Positive. Understand? So, M1 V1, which is equals to M1 U1 plus M2 U2. Now you can see, I can rearrange this. Both are positive. I can write 1 plus 2 or 2 plus 1. Both are same or not? Both are same or not? So I can say M1 V1 plus M2 V2, which is equals to M1 U1 plus M2 U2. So if X equals to Y means I can write Y is equals to also X. Yes or no? Yes, I can write reverse.
Yes.
Now M1 U1 plus M2 U2, which is equals to what? M1 V1 plus M2 V2. So this is only what we used to call. What we used to call law of conservation of momentum. Yes or no? Please respond.
Yes, sir.
Conservation of momentum. So we have been proved that momentum before collision, which is equals to what, guys? Momentum before collision is equals to what? Momentum after collision. Is it right or wrong? That's all. So this is what derivation for law of conservation of momentum. So I will slowly display. Please try to solve from there. So that is what. If I will apply force, whose body will change? Body 2 will be affecting. If body 2 is affecting force, then who will change? Body 1 will be affecting. So if you'll remember that logic, then everything will be very simple. Yes or no? Everybody? Yes?
Yes, sir.
That's all. So please all of you start solving from here. Any doubt anyone can ask me. See, very clearly I taught. So nobody should do any mistake in that. Neatly how to do it. Now, anybody is not understand anywhere, please ask me. I will explain. So now slowly I'll roll. You please note it down. Any step you have doubt, please ask me. Immediately I'll explain now itself. Please make it. Gokul, have you understand Gokul?
Yes, sir.
Danishkar, you? So we can say total momentum before collision, which is equals to what? Total momentum before collision, momentum, you have to keep it. Total momentum total momentum before collision is equals to total momentum after collision. Is it okay, everyone? So that is what you have to remember. Total momentum after collision. Write it from the beginning. Hari, have you understand? Hari, ready? This
Yes,
is
sir.
U2.
Yes, sir.
Yes, sir.
Remember. Yeah. Please write it. V2 minus U2. Do it. Can I display from here first? Already you written this one in yesterday's class. Till here. Is it as? Now only conservation of momentum, I think you have to write it. Conservation of momentum, next neatly write it. Newton's third law, action equals to reaction, like that. That is what, everything you have to write it. Completed means tell me, I will go down. Yeah, completed everybody. Next, yeah, continue this one. Slowly write, no issues, but you have to improve. That is what I want. Nobody should do mistake. Okay, so that is what you at it. I think. Hope you all understand. Yes or no? You understand or not?
Yes, sir.
Yes,
Yeah.
sir.
Very simple definition actually. It's not a big deal. Actually, if you understand the F1, F2 logic, then everything is very easy. Yes or no, Ari?
Yes, sir.
Yeah, that is what. So if body 1 is applying force, then whose velocity will change? Body 2 velocity will change. Okay. It is decreasing or increasing, doesn't matter. If body 2 is applying force, then whose velocity will change? Body 1 velocity will change. Okay. So that is what you have to remember. Clear, guys? Can I scroll down?
Yes, sir.
Next. Next, can I go down?
Yes.
Everybody understand or not? Okay, next. Tanishkar, have you understand or not? Tanishkar, are you solving?
Yes, sir.
Okay, good. Any doubt, ask me any step. See, slowly, even like a kid's thought. So you have to understand and you have to do it. Yeah, any doubt here?
No, sir.
Okay, good. Next. This is what it is. This derivation is very important for even, this chapter, this is the most important derivation. So this is the only one derivation we have. So kindly you have to learn well, okay?
Okay, sir.
Yeah. Just make it fast. So finally we have been done that what? Total momentum before collision is equals to total momentum after collision.
Collision.
Okay, that is what you have to prove it.
Completed, sir.
Okay, others? Yeah. That's fine. Finish it fastly.
Completed, sir.
Yeah. So now if we'll come to here, applications of law of conservation of momentum. So then you can keep heading. So whatever we are studying, the Newton's third law. Newton's third law, so many applications we studied. Do you remember? Yes, please. So same way, here also if it comes to know, so applications of law of conservation of momentum. Same thing like applications of Newton's third law, conservation of momentum. So if we take, now for example, we all people know what is the Newton's third law. Newton's third law, which says that every action there is an equal and opposite reaction. That is what we studied. Yes or no, guys? So if we take for example, jet aeroplanes. Jet aeroplanes will work on the principle of what? Jet aeroplanes. We know that rockets and jet aeroplanes, we studied already.
Yes,
Rockets.
sir. Newton.
Yes, please. Rockets and jet aeroplanes will work in the what principle? Rockets,
Newton's third law.
jet aeroplanes will work on the principle of action and reaction. Is it yes or no? Action and reaction. This is only what we used to call Newton's third law. Yes or no? Now, we will describe now the same way you can see working of rockets and jet aeroplanes according to the law of conservation of momentum. Same thing. Now, what is the general principle of rockets or jet aeroplanes? Tell me, for example, if I'll take rocket. So what is the general principle if I'll take? What is the general principle? So the amount of gases will come outside. So that is what we used to say gases. Hard gases will be coming back. So that is what we used to say. What is that gases? Action. Yes or no? So when the gases are released by the engine, that is what combustion of fuels, then gases will come down. That is what action. So these gases will apply the opposite force. That is what we used to call as reaction. So that is why
Reaction.
is going up. That is what we studied, space jet and everything. Is it yes or no, like balloon experiment? Yes, please. Now, that is what we can say action is equals to reaction. Now, we have to prove this one same thing like law of conservation of momentum. So if you notice it here, the chemicals inside the rocket and they will produce understanding. They will burn and produce high velocity blast of hot gases. Yes or no? Inside the engine, if you notice it, inside engine, what will happen? Gases will burn. Gases burn and they will produce what? Like fuel. Fuel means, sorry, engine inside, not gases. Fuel will burn and will produce high velocity of gases. Is it yes or no, guys? Please respond. High velocity of hot gases. Is it right or wrong, everybody? Yes, please. So these gases pass out through the tail or nozzle of the rocket in the downward direction with a tremendous speed or velocity, and the rocket will move up in the balance the momentum of the gases. So that is the principle of although you can take here masses of gases is emitted by is very, very small. Understanding? You can notice it here. The engine will burn the fuel and it will releases high velocity of the gases, but their mass is less or more. Mass of the gases is less compared to the mass of the rocket. But that momentum of the gases, what is the total momentum of gases, everybody? Gases momentum is equals to what? Mass of the gases into velocity of the gases. Is it yes or no, Hari?
Yes, sir.
Now, of course, its mass is less, but who is more? Velocity is very, very high. So if you multiply this one, then whose mass is more? Rocket mass is more. Do you understand? Everybody, our pilot or even the aeroplane mass is more. Rocket mass is more, but velocity is what? Mass is more, but velocity is what?
Low.
Velocity is less. But to balance the momentum of the gases, the rocket will go up. So the momentum of rocket or aeroplane, if we'll take, which is equals to what? Mass of rocket into what is that? Velocity of rocket. But here velocity of the rocket is less or more? Velocity of the rocket compared to the gases. Compared to the gases, it is less. But still the both moments are equal or not? Both momentum are equal or not? the momentum of gases, which is equals to what? Momentum of rocket or aeroplane. That is what? Law of conservation of momentum. So you can say here, even though the amount of the gases emitted by them is comparatively small, means mass is less, but they have very high velocity, so that they'll produce large momentum or small momentum. Velocity is high means velocity is high, so they will produce large momentum or small momentum. They will produce large momentum, because as we already studied, momentum is directly proportional to velocity, momentum is directly proportional to mass. Both are right or wrong? Yes, please. That is what. So next one. So the tremendous speed of velocity of gases only causing to move the rocket in the upward direction. Now, if we take the momentum imparted to the rocket is in opposite direction. So in spite of its large mass, the rocket goes up with a high velocity because of huge